In section 2.2 and section 4.1, we'll study linear equations. We'll really focus on linear equations on two variables. These are equations of the following form. Here we have two variables x and a variable y, and then the values a, b, and c are real numbers. The solution set of these types of equations are lines. And a solution set is a set of numbers that make these equations true. In this first section, 2.2, we'll discuss and review properties of lines and line segments. In part A, we'll review different equations for a line. In part B, we'll see how to write parallel and perpendicular lines. Then, in part C, we'll review how to solve rational equations. As we noted before, a linear equation on two variables is a line. In this section, we'll review three main ways on how to write a line, these being point-slope form, slope-intercept form, and standard form. Each of these equations will have certain advantages when writing them. Let's go ahead and look at our first form. Slope-intercept form is the most common way to write a line. This form is given by the following equation: y is equal to mx plus b, where m is the equation of the slope and x is the equation of the b is the point for the y-intercept. This equation is extremely useful and actually tells us something very important about lines. Lines are determined by 2 points. Let's go ahead and look at a picture of why this is true. Suppose we're given our xy plane. And we're given 2 points. Let's call this point x1, y1, and we're given this point x2, y2. If we draw a line through these 2 points, then what this equation for a line is telling us is that if we can find the slope and we can find the y-intercept, then we can find an equation for the line. Recall again that the slope is the change of y over the change in x. So given 2 points, we can always find the slope of a line. Then, since we know the slope and we know a point on the line, we can solve for the y-intercept always. Then, once we have the slope and the y-intercept, we have an equation that determines the line, which comes from just knowing 2 points ahead of time. Again, this tells us the useful fact that lines are determined by 2 points. Let's compute an example. Example 1, find the slope-intercept form of a line that goes through the following 2 points. To solve this, let's go ahead and find the slope first. M, again, is going to be y2 minus y1 over x2 minus x1. Then we're going to see that this is 3 minus a negative 1 divided by negative 5 minus 2. Simplifying this is going to be 4 divided by a negative 7, which is negative 4 divided by 7. Plugging this into the equation, we're going to get y is equal to negative 4 divided by 7x plus a b. So we need to find our y-intercept, and to do that, we know both of these points lie on this line. So if we plug one of these points in, we can go ahead and solve for b. So let's go ahead and plug in the point 2, negative 1. Y then is going to be a negative 1 is equal to a negative 4 divided by 7 times 2 plus b. Let's start a new page. Simplifying the right-hand side, we'll get a -1 is equal to a -8 divided by 7 plus b. Then we see that b is going to be equal to a -7 divided by 7 plus 8 over 7. This gives us b is equal to 1 divided by 7. We found our y-intercept. We can go ahead and plug this in to the previous equation, and we get y is equal to a -4 divided by 7x plus 1 divided by 7. And this is the equation of our line. So while slope-intercept form tells us that 2 points will always determine a line, another way we can determine a line is if given a point and given the slope, this is also enough information to determine a line uniquely. And if we have this information, we can plug it into an equation called the point-slope form of a line. Here, in this equation, given a point x1, y1, we plug that information into our equation, and then also given a slope, we plug this into our equation. Again, these two pieces of information will uniquely determine our line. Let's go ahead and compute the equation of a line in point-slope form. Suppose we're given a slope of m is equal to 4. Then let's go ahead and find the point-slope form of the line passing through the point 2, 3. To solve this, we have that our slope is equal to 4. We have our point 2, 3. We're just going to plug this into the equation of the line. We'll have y minus 3 is equal to 4 times an x minus 2. And this is the equation we're looking for. Now we're going to turn our attention to the last form of a line, and this is standard form. We saw standard form at the very beginning of the section when we were talking about linear equations on two variables. This form is used in linear algebra and to model linear systems. This form is also very useful if you ever study Calculus 3, because we can also form the equation of planes using this type of formula. For now, let's again just focus on lines, and we're looking at the standard form. The standard form of a line is given by the equation ax plus by is equal to c, where we have that a, b, and c, these are all real numbers, and x and y are variables. Let's find the standard form of a line given some information. Example 3. Find the standard form. Of a line with slope 5 and passing through the point 1, 4, 3. First, let's put this in point-slope form, and then we can solve it for standard form. Here we have y minus 3 is going to be equal to 5 times x minus 1/4. Let's simplify the right-hand side, and we'll get y minus 3 is equal to 5x minus 5 divided by 4. Then we need the constants on one side and the variables on the other side. So subtract our 5x from both sides, we'll get 5x plus y, and then add 3 to both sides. We'll get 3 minus 5 divided by 4. Simplifying the right-hand side, we should get that this is going to be 7 divided by 4 on one side, and on the right-hand side on the left-hand side we'll get 5x plus y. And so this is going to be the equation of our line in standard form. To finish off this section, we're going to go ahead and review horizontal and vertical lines. To do this, let's go ahead and just draw a picture. Here will be our horizontal line. Here we have a vertical line. And again, what we're saying in a vertical line is that all x values are going to be held constants, but the y values can be any y value you want it to be. So the equation of a vertical line is where we hold the x values constant, and so we say x is equal to whatever constant we want. And we say the slope of a vertical line is undefined. Again, because when we use the equation for slope, we have 0 in the denominator, and that is not well defined. Then, for a horizontal line, we hold all the y values constants, but the x values can vary and be any value you want it to be. So the equation of a horizontal line is given by y is equal to some constant c, and we say the slope of a horizontal line is 0. Again, if we look at the equation for slope, we see that we'll have 0 in the numerator, which makes the entire slope 0 itself.